All right, so our grade 9 review continues. So we're going to be looking at forming ions. So again, some of you might be really great at this, but we're going to remind ourselves of how ions form. When we look at compounds later in this unit, you will have to know the charge of an ion off the top of your head. So in order to do this, you have to understand what an ion is. So just a reminder, an ion is a neutral atom. A neutral atom has the same number of protons and electrons. So when you're looking at an atom, and that's what we looked at in previous times, atom has an equal number of electrons and protons. It has an equal number of positives and negatives. If an atom loses or gains an electron, it then becomes an ion. So an ion is anything that has a positive charge or anything that has a negative charge, anything that's gained or lost an electron. We have the octet rule that defines whether or not an atom is going to gain electrons or whether or not it's going to lose electrons. So what the octet rule says is that atoms are most stable when their valence shell is full. So ideally, the most stable atoms that you can see on the periodic table are the noble gases that have full valence shells. Anything that doesn't have a full valence shell is going to want to gain or lose electrons in order to become full. Why is it called the octet rule? Oct actually means, that's not what I wanted to do. Oct actually means 8. So when you think of it, outside of hydrogen and helium, which are on the first shell, the second shell, the third shell, the fourth shell, all of those want 8 electrons in order to be full. So it's called the octet rule because most atoms are looking to have 8 valence electrons in the outside shell. So the octet rule is always going to ask you, is it easier to gain electrons to get to 8, or is it easier to lose electrons to get to 8? Because of this, we actually have two different types of ions. We have cations and we have anions. So cations are positively charged ions. To become positively charged, that means you must have lost electrons. So just a reminder that only electrons can move. Electrons are on those outside shells, those outside orbits. Protons are in the nucleus, they can't move. So in order to become positive, I can't gain positives. I must then lose negatives. So positively charged ions have lost electrons. Those are called cations. For those of you that are going to help you remember this, I'm going to draw my beautiful version. We all know I'm not an artist. That looks like a cat, right? So those of you that are cat lovers out there, you love cats. Cats are a positive thing to you. A cation is positive. Those of you that aren't cat lovers, pretend you're a cat lover, and cations are said to be positive. You love cats. Anions, on the other side, are considered to be negatively charged ions. They're negatively charged because they gained electrons. So again, only electrons can move. I can't lose positives. I can't lose protons. So anions are negatively charged ions. I gained electrons. I like to think of this like an onion. So we're going to draw ourselves. That's a pretty good onion, right? Onions are negative. Onions make you cry. No one likes to cry. So anion kind of sounds like onion. Anion are negative. They've gained electrons. They've got an overall negative charge. Now that we understand the two different types of ions, cations and anions, let's try to take a look at how these might actually form. So ions are actually going to achieve their charge, by gaining or losing electrons, depending on how many they have. So our rule of thumb is if you have less than 4, you're going to lose electrons. So if you have less than 4, it's easier for you to lose than to gain to get to 8. If you have more than 4, it's easier for you to gain than to lose. So if you have more than 4 electrons, you're more likely to gain electrons. You're more likely to have a negative charge. So if you're losing electrons, you're going to end up having a positive charge. So less than 4, you're going to have a positive charge. More than 4, you're going to have a negative charge. The great question is, what happens if I have exactly 4, right? So what happens in cases like carbon, where I have 4 valence electrons? The easy answer is it could actually go either way. You could have a positive charge or a negative charge. The more accurate answer is those actually tend to not form ions. They tend to not form ions. They're involved more in covalent bonding, which we're going to talk about covalent bonding later on this unit when we get closer to it. So ions can be represented by Bohr-Rutherford diagrams. We're going to draw those in a second. Ions can also be represented by the Lewis symbol. So Lewis diagrams, I showed you how to draw Lewis diagrams. Lewis diagrams are a much easier way to show what is happening with an ion. So a Lewis diagram is going to take the symbol. So for example, if we're talking about sodium, the symbol for sodium is Na. It's going to enclose them in square brackets. So square brackets are like the international symbol for ion. We're also going to use it to represent concentration later. We'll get there later. But if I see square brackets around an element symbol, then I know I'm talking about an ion. One of the most important pieces of information for an ion that you want to include is the charge. So you're going to go ahead and you're going to place the charge for whatever your ion is outside the bracket. And notice this is actually a superscript. So I didn't write it like this. I didn't write Na square bracket with a really big plus beside it. I wrote Na square bracket with a little plus up here. If it's just a charge of +1, you don't have to write the 1. You can if you want to. Looks kind of weird though. If it's a charge of 2, so if it's calcium, which has a charge of 2+, you do in fact have to write the 2 to tell me that it's got 2 additional positives. It's got 2 extra positives. It doesn't matter if you write the 2 first or if you write the plus first. I'm never going to take marks off for that. You just want to tell me how many extra positives you have. Let's take a look at our example. Let's take a look at sodium and how we actually would draw a Bohr-Rutherford diagram for an ion of sodium. So here we've got the sodium atom. So if you're going to draw a Bohr-Rutherford diagram for sodium, you're going to find that we actually have one valence electron for sodium. So we can see our lone kind of valence electron up here for sodium. Your big question is, first of all, does sodium have a full shell? It does not. The outside shell is not full. I have one valence electron. So then your next question is, how could I become full? You have two options. You could gain 7 electrons to become full, to fill that outside shell, or you could lose 1 electron, and then that shell underneath is going to supplement as a full shell. So the question is it easier to gain 7 or to lose 1? Obviously, it is much easier to lose 1. So if we lose that outside valence electron, I'm going to be left with a total of 10 electrons, and I'm going to be left with a total of 11 protons. That means overall, I've got 1 extra positive. Since I have 1 extra positive, sodium is going to have a charge of +1. So if I was going to represent this as an ion, I would go ahead, I would, actually, let's redraw this for good. Right? So we're going to have sodium. We're going to do Na. Let's erase this. Let's do things right. So Na would go in the middle. I've got 11 protons. I've got 12 neutrons. I've got my first shell, which has 2 electrons in it. I've got my next shell, which has 8 electrons in it. It's full. And I've lost that outside electron, so I'm not going to bother to draw that last shell. To show that this is an actual ion, I have to have my square brackets. Oh, come back. Let's try that again. I have to have my square brackets. So square brackets tell me that it's an ion. It's not equal numbers of positives and negatives. And what's my overall charge? Well, my overall charge is a 1 in this case, positive. Now, again, you could draw the Lewis diagram of this. The Lewis diagram of this would just be, let's draw my valence electrons. My valence electron for sodium, I would have 1. Now, again, is it easier to gain 7 or is it easier to lose 1? It's much easier to lose 1. And since it's an ion, I have to do my square brackets. It has an extra charge, it has an extra proton, so it's going to have a charge of +1. So you can actually pick and choose which one you want to draw. To me, Lewis diagrams are much, much, much easier, but not all students are comfortable with them. Now we want to talk about the overall trend. So again, hopefully something you remember from grade 9, but you might not. A shortcut for telling the charges for ions. Sodium has a charge of +1. Lithium also has a charge of +1. In fact, anything that's in that first column on the periodic table has a charge of +1. So if I were you on your periodic table, if you have a paper copy, I would go ahead and I would write a big +1 at the top of that column, because anything that's in that first column has a charge of +1. Down here, beryllium has a charge of 2 plus. Calcium's going to have a charge of 2 plus. In fact, anything that's in that second column is going to have a charge of 2 plus. So on my periodic table, I would go ahead and I would write a big plus 2 at the top because anything that's in that column is going to have a charge of plus 2. And for our next one over here, boron is going to have a charge of 3 plus, and aluminum is going to have a charge of 3 plus. And you guessed it, that next column, that 13th column, is going to have a charge of plus 3. So I would go ahead on my periodic table and I would write a plus 3 at the top there, just so I always know that anything in that 13th column is going to have a charge of 3 plus. Going to make it much easier when you have to kind of predict charges off the top of your head when we're talking about ionic compounds next time I see you. All right, now that we have a little bit of information about this ion, let's try our other ion. We're going to do another example here, if this ever loads. We're going to take a look at chlorine. So this time, we're going to take a look at what's going to happen if we have something really far on the right-hand side of the periodic table, if we have a nonmetal. So chlorine is an example of a nonmetal, and the first thing you have to ask yourself, once we have our Bohr-Rutherford diagram, is it full? The outside shell, is it full? It's not. I only have 7 on the outside shell. So now I have to ask myself, is it easier for me to gain 1, or is it easier for me to lose 7? I'm really hoping that you're all going to say gain 1. So I'm going to take a shortcut here. I'm going to go ahead and I'm going to add 1 electron to my outside shell. Since I now have an uneven number of negatives and positives, I'm going to go ahead and I'm going to put square brackets, because it's an ion now. And now you have to tell me what the charge is. Well, in this case, I've gained 1 negative. So overall, I've now got 18 negatives, and I only have 17 positives. So that means that my charge overall is going to be 1. You can write negative, or sorry, it's going to be -1. You can write -1 if you want, or you can just write that negative. So chlorine has a charge of -1. So this is how we draw the Bohr-Rutherford ion for chlorine. If we wanted to draw the Lewis diagram, same idea, we're going to have chlorine. Chlorine has 7 valence electrons. So we would draw our 7 valence electrons around the outside. Chlorine is going to go ahead and it's going to gain a valence electron. So I'd add my 1 valence electron there. I'd have my square brackets around it. And chlorine's got a charge of -1. So again, you can choose to draw the Lewis diagram. You can choose to draw the Bohr-Rutherford diagram. To me, the Lewis diagram is much easier. Chlorine has a charge of -1. Fluorine, I'm going to go over here. Chlorine has a charge of -1. And fluorine, which is on top of it, also has a charge of -1. So anything that is in that halogen column, that 17th column, is going to have a charge of -1. Ooh, I got a package. That's exciting. I'm sure my dog's going to go crazy in a second. Yeah, there it goes. Hi, buddy. So anything that's in that 17th column is going to go ahead and have a charge of -1. So if I were you, I would go ahead and I would record that -1 on the periodic table. If we take a look at our next column, oxygen here has 6 valence electrons. Since oxygen has 6 valence electrons, it's going to want to gain 2 negatives. That means oxygen is going to have a charge of -2. So anything that's in that 16th column on the periodic table has a charge of -2. And then if I take one step over, let's take a look at nitrogen. Nitrogen has 5 valence electrons. Nitrogen's going to want to gain 3 electrons. 1, 2, 3. That means that nitrogen is going to have an overall charge of -3. So anything in that 15th column is going to have an ionic charge of -3. So again, on your periodic table, I would probably write those numbers down or have them memorized. You learned that in grade 9, but it's a nice little overview. So that way you know off the top of your head what the charge of those ions are going to be. So that actually pretty much wraps up our review. That is everything that you need to know from chemistry from grade 9 and 10. So we are ready to move on to new content. So exciting. So I'll see you in the next video when we start talking about our new grade 11 content. Have a great day. See you later.